Is it recording? I think it is recording now. Great. Awesome. So the first question was to find all the asymptotes, including the oblique asymptotes to the curve y is equal to square root of x squared plus x minus x. Now, let's start at, well, let's look at the domain of this function. What is the domain of this function? Domain, we need that x squared plus x is bigger or equal to 0. So x times x plus 1 is bigger or equal to 0. So the domain really is minus infinity, minus 1, closed, union, 0, infinity. Right? Isn't that right? Now, f is continuous everywhere in its domain by keeping in mind that continuity at minus 1 and 0 are defined by right and left continuity. On its domain. So there is no vertical asymptotes. So no vertical asymptotes. Now, let's look at the horizontal asymptotes. And you can test for horizontal and oblique at the same time, but let's do them step by step. Okay? So let's look at plus infinity. Or let's start minus infinity. At minus infinity, what is the limit as x goes to minus infinity of f of x? Do you want to do them both at the same time? Do you want to test for them both at the same time? So the idea, what is a horizontal asymptote? It's an oblique asymptote, but with 0 slope. Right? You guys see this? If you have an oblique asymptote with 0 slope, then it's horizontal. Okay? So let us calculate these things. Where do you want to start? Let's start at plus infinity, at minus infinity. Limit as x goes to minus infinity of f of x over x. Square root of x squared plus x minus x over x. Now what do I do? Infinity. Well, I have infinity over infinity, right? This is infinity. This is minus minus infinity. So I have infinity over infinity. Now here, okay? Now let us try to factor the highest power. It's the square root of x squared. 1 plus 1 over x minus x over x. Now, what is the square root of x squared in general? The square root of x squared is equal to what, everyone? It's the absolute value of x. So this is the absolute value of x over x. No, x is negative. What is the absolute value of x? It's minus x. Over x. Great. Now I can factor an x out. I can cancel an x out. Can I do it quickly? Can I just cancel all of these x's? Yep. It's minus square root 1 plus x minus 1. 1 plus 1 over x. Minus 1, which is minus 2. Okay? Did you all get this? Did you try this one? Yeah? Did you try them or not? Yeah? Did you get the slope is minus? Great. Now, I need to find the intercept if I have an oblique asymptote. So what do I have to do? I have to look at limit as x goes to minus infinity of f of x minus 2x. What is that equal to? This is just the limit as x goes to minus infinity of f of x plus 2x Now, what is f of x plus 2x? Square root of x squared plus x minus x plus 2x. So this is just the square root of x squared plus x minus x plus 2x. So this becomes plus x. And then we know how to evaluate this limit, don't we? Try to plug in, you get infinity minus infinity, indeterminate 4. So what do? I multiply by the conjugate on top and on the bottom. So far, so good. So far, so good. Then what do we get? On top, what do I get? X squared plus x minus x squared. So I have an x. And on the bottom, minus x. Now what do I have here? I can just factor out. I can just factor out. Let's see, what do I get? Yeah, so I'll do the same thing. This is just, I'll do it quickly, okay? Or, well, it's root of x squared, root of 1 plus 1 over x minus x over x. I mean, it's the same limit that you had before, I think. Is it the same limit as you had before? Oh yeah, it's the same. Is it the same? It's 1 over that, right? You guys see that? You guys see it's 1 over this? Yeah, it's the same one you had before. I don't know why I redid the calculation, but that's fine. That's fine. So let me see. Yeah, so x, absolute value of x, square root of 1 plus 1 over x minus x. And then you cancel. What do you get? You get minus 1/2, right? Yeah? We got this or not? Did we get this? So an oblique asymptote at minus infinity is minus 2x minus 1/2. I have an oblique asymptote. Y is equal minus 2x minus 1/2. Did we get this one, everybody? Yeah, and you, yes?
How come in funding domain you ignore that negative x?
I ignore?
That minus x after 0.
What's the domain of minus x? Part, right? So it doesn't play a role. Okay.
And how come you don't have a bracket with -1 to 0? You're saying that it's underlined.
I have a closed bracket. Yeah, because you can still plug in 1 in that equation.
Right.
Minus 1, 3. Right? It will just give you 0 minus minus 1. And you can still plug in 0, right? The square root would be the square root of 0.
But you don't have a union between -1 and 0.
I do. Oh no, you mean between minus 1 and 0? It's not included, that's true. Yeah. So you just remove that segment. The segment from minus 1 to 0, you remove it.
How do you know it's not minus?
Because you need the element inside the square root to be non-negative. Okay?
Okay.
Yes. Can I help? We're good? Can I help? Yeah? You're all good with this? I think you should be very comfortable with this stuff. Okay? Great. Let's look at one more limit. We have the asymptote at plus infinity. I mean, at plus infinity, what do you expect? Personally, I expect a horizontal asymptote, right? You guys see this or not? From experience, you can just say that there's a horizontal asymptote. You just have to find it. So let's look at infinity. Literally, it's the same steps. Anything? Yeah, guys, I don't know why everybody's talking. Any questions? So I think, please, when I post problems, please try them. Don't just stare at them. Okay? So it's good to try them. I think it will benefit you. And I think it's a good amount of practice that you're gonna have. I mean, the exam is in like 20 days, something like that. I don't know when it is. 20 days. December 5th. Today we're the 24th, 25th. I don't know. Let's see. Okay, so this is the absolute value of x. I mean, really, it's the same. It's the same music all over again. What do I have here? Minus x. Oh my god, why am I doing this? Anyways, I'm testing for oblique asymptote. So what do you have? You have square root of 1 plus 1 over x minus 1, which is 0. So if you have an oblique asymptote, what is the slope of the oblique asymptote? It's 0, right? So what you're looking for really is a horizontal asymptote. Okay, let's do it here. Okay, that's a long question. Oh. Of f of x minus 0x okay, should I do it entirely or you know how to do it? Do you know how to do this or should I do it? Is that fine? I can do it? Okay. What is that? This is just infinity minus infinity. And this is just you multiply by the conjugate. Again, you should be very comfortable with this stuff, even if it's primitive stuff. But you can see how we can relate things, right? We can test you on primitive stuff using oblique asymptotes and things like that. So, like, please. Great. X squared plus x, blah, blah, blah. This is x on top. And then we factor an x squared out. Square root of x squared. Square root of 1 plus 1 over x plus x. And then what do I have? So it's x, absolute value of x plus x. Now the absolute value of x is equal to x, so I will cancel this. I'll do all the required cancellation. So what do you get? X, 1 over square root of 1 plus 1 over x plus 1, and you get 1/2. Okay, so at infinity, you have a horizontal asymptote, which is the line y is equal to 1/2. Okay, did we all get this? Okay. And very good for those who tried the problems. Great, let's look at the next one. Next one is nice. Show that for x bigger or equal to 1. Any questions on this? Any questions on that? Yes.
How is that another graph? Is it the horizontal asymptote or the
Yeah.
asymptote is going like this and then it goes like this?
Yeah, but the horizontal asymptote is where?
Positive.
And the negative asymptote, it's at negative infinity. So do you really care what happens? So it goes like this, and then it goes like that.
Okay.
Right? You see that or not?
Yeah.
I mean, sketching the curve is not easy in this case. You get a nice. I mean, it's a good exercise to sketch the curve. I mean, I think it's a question from the book, which I said to sketch. So when you try to sketch it, you have to pay attention that from minus infinity, like for large negative values of x, the curve is going down, and for large positive values, the curve I think is going up this way, right? But I think well, no, wait a second. Yeah, no, it's going up, right? You see that, right? It goes up from 0 to 1/2, right? So really, you don't have to. Horizontal asymptote at minus infinity has nothing to do with horizontal asymptote at plus infinity. When you sketch them, you just sketch them differently. Okay? Great. Awesome. Now, the second question. Show that cos inverse of 1 over x show that for x greater or equal to 1, cos inverse of 1 over x. Who can give me sine? Is it sine of square root of so cos sine inverse? Thank you. Sine inverse of square root. So let's see. Is that right? Is it the one? Great. Okay, so who wants to help? Who wants to try and attempt how to do this? Yes?
You can make cos, like arc cos 1 over x equals cos theta equals 1 over x. And so you can say that the adjacent and the hypotenuse adjacent.
Ah, very good. You can do that with geometry. Yeah.
Yeah.
You can do that with geometry. But let's say I want to use the MDT. Okay? Let's say I want to use the MDT. So really, yeah, you can do this. I mean, you don't need, for all of the questions we have done, we don't need the MDT, right? I think I said that at the beginning, but it's good to try to do it with the MDT because if they get complicated, you may not be able to visualize them. And so here you have to justify a bit more because if I give you here, you were lucky because 1 over x is positive, right? So cos inverse of 1 over x would be an angle between 0 and pi by 2, right? So you have to justify that before you use any triangle, right? But say for example, I give you a relation for x is less or equal than -1, then that doesn't work. You see what I'm saying?
Yeah.
Then you couldn't. But that's a good idea. Let's write it down. I mean, using geometry. I mean, really, for all of these things, you can just do it with trigonometry, right? You don't need even in the book, the ones in the book also you can just do this using trigonometry. But I mean, I think use the MDT just to get good practice. Now, really, what is? I mean, so if theta is cos inverse of 1 over x, theta is between 0. Cos inverse. Theta is between 0 and pi by 2, right? And you have to take care of when theta is pi by 2 and when theta is 0, right? So you have to do some work. But the idea is that, I think you'll see this more next semester. So cosine theta will be 1 over x. So the cosine is the adjacent over the hypotenuse. So you have 1 over x and 1. So what is tangent theta? Tangent theta is the opposite over adjacent. So the opposite is the square root of 1 over x squared divided by 1 over x and you have x squared minus 1 over x squared divided by 1 over x. Wait. Oh, you're looking at sine. Sorry. Sine of theta. Yeah. Okay. Yeah. Okay, so you can do the trigonometry. But let's use the mean value here. Again, if you do it with trigonometry, you have to justify a bit more. That 1 over x is between 0 and 1 over x is between 0 and 1. So if x is strictly bigger than 1, you can look at cos inverse of 1 over x as a, what do you call this type of angle? Like this one, not obtuse. An acute angle and a right angle triangle. And then you can do this again. And then you have to consider the cases where x is 1, basically. And then, when cos inverse 1 over x is pi over 2. So as x goes to infinity, you have to do all of these things. But let's try to do it using the MBT. How could we do that? We've done this like millions of times so far. Probably someone who, yes,
Take the derivative of both sides.
of both sides, okay. And then what should I be getting?
The same
They're equal, and then this allows me to say that I differ by a
constant.
constant, and then I have to find this constant. Thank you. Yeah, that's it. So here, let f of x is equal to cos inverse 1 over x, and g of x is equal to sine inverse. Okay, I'll leave it to you as an exercise. Fully justify that f and g are differentiable on 1 infinity and continuous Okay, I mean, this is obvious. Why? Because do it 1 over x is differentiable on the open interval 1 infinity, and cos inverse is differentiable on, so the values of 1 over x are from 0 to 1, right? And then cos inverse is differentiable there. So all of this imply that cos inverse 1 over x is differentiable on the open interval 1 to infinity and continuous on 1 infinity as the compositions. Well, I think as I'm writing, I'm giving more and more justifications as the compositions of differentiable and continuous functions. Okay, great, awesome. Now, let's look at this now. What is f prime of x? So for all x bigger than 1, f prime of x, what is the root of cos inverse? It's minus 1 over square root of 1 minus t squared. So it's 1 over x squared times the derivative of 1 over x, which is minus 1 over x squared. Let's write this nicely. Oh, okay. Oh no, wait. Okay, great. Now let's look at this. F prime of x is equal to what? It's 1 over square root of x squared minus 1 over x squared, right? Times x squared. Now, try to write it nicely. I mean, well, who knows? No, you try to write it nicely. Always try to simplify it in a nice way. So it's 1 over square root of x squared minus 1. The square root of x squared is the absolute value of x times x squared. Now notice that the x is positive. X is bigger than 1 here. So the absolute value of x is equal to x. Over x times x squared, since here, let's write this one here. Square root of x squared is equal to absolute value is equal to x, since x is strictly bigger than 1. And let's write this nicely. This is just 1 over x square root of x squared minus 1. Okay? Really, this is just a type of secant. Secant inverse of x. Yes, sir.
In the derivative, how did you swap? Because it's negative 1 over 1 over square root 1 minus 1 over x squared.
Yeah.
So x squared minus 1.
I cleaned the things inside the square root. I put them inside on the same denominator. Right?
Oh, yeah.
Okay. Great. So now, what do I have to do? I have to look at g prime of x. Oh man, g prime, I'm afraid to differentiate that. Let's see. G prime of x, what is that equal to? This is 1. The derivative of arc sine is 1 over root 1 minus d squared. So it's, oh man, oh no, that's a nice one. Times the derivative of square root of x squared minus 1 over x. What's the derivative of square root of x squared minus 1 over x? What do I use? I use the quotient rule. So it's x over square root of x squared minus 1, or let's put 2x to the square root of x squared minus 1 times x minus square root of x squared minus 1 over x squared. Let me put my x's in one way. Okay, great. What is that? This is just 1 minus x squared minus 1 over x squared. Wait, what? There's something wrong here. Oh no, that's good. Okay, now let me put everything on the same denominator. Let me clean that up. So it's 2x squared minus, or it's x squared minus x squared minus 1 over x squared square root of x squared minus 1. So g prime of x, what is g prime of x equal to? So what do I get? I get square root of 1 over x squared and on top I get 1 over okay, so what do I have here? I have it's 1. I put the x squared on top, so I get square root of x squared times 1 over x squared, square root of x squared minus 1. Now the square root of x squared is the absolute value of x. Is equal to x, since x is strictly bigger than 1. So you have an x divided by x squared, square root of x squared minus 1. And then, boom, very nice. Okay, So you get that f prime is equal to g prime after all this thing. Okay? Again, if you attempted this, it shouldn't be that hard. Just a messy differentiation that you have to deal with. Oh, that you're right here, and let's use this board. Oh, I use it. Well. So f prime is equal to g prime on 1 infinity. And hence, f of x is equal to g of x plus c for x strictly bigger than 1, where c is a constant. Now, since f and g are continuous, on 1 infinity, then f is equal to g plus c on the whole closed interval 1 infinity. To find c, plug in x equal 1. So you get f of 1 is equal to g of 1 plus c. Of course, you want to find 0, right? So you have cosine inverse of 1. What is g of 1? Is sine inverse of 0 over 1 plus c. Cos inverse of 1 is 0. Sine inverse of 0 is 0 plus c. So c is equal to 0. Hence, f of x is equal to g of x for x bigger than 1. Always try to write down the conclusion. Cos inverse of 1 over x is equal to sine inverse of square root of x squared minus 1 over x for x greater than or equal to 1. Okay, are we good here? I'll try to give you more practice on this stuff, and please do that. Okay. Great, awesome. Oh man, there's we did 2 questions so far. Okay. We have curve sketching and l'hôpitals. What do you want to do? Let's do the l'hôpitals one. I mean, that should be quicker. And I have some related rates as well. Okay, great. Okay, let's look at this. Limit as x squared goes to plus infinity of x squared e to the minus x. What's the first thing I do? Plug in, what do I get? X squared goes to infinity, e to the minus infinity is 0, so I have infinity times 0. That's an indeterminate form. Can I resort to L'Hopital's rule here, or I have to do something? I have to do something. So what I would suggest is that to bring the e of x down, And then what do you get? You get infinity over infinity. By L'Hopital's rule, it's 2x over e to the x, which is still of the form infinity over infinity. And I apply L'Hopital's rule again to the 0. Okay? Is that obvious? Is that good? Everybody, is that good?
Yeah.
Yeah? Now let's do one more. I have one more, right? It's close to x over to the 1 over x squared. X the limit. As x goes to 0 of cos to x of 1 over x squared. Great. What's the first thing I do? I plug in. Cos to x goes to cos 0, which is 1. 1 over x squared goes to infinity, so it's 1 to the infinity, which is an indeterminate form. How should I proceed from here? How should I proceed? Anyone who attempted the questions? Yes. Exactly, thank you very much. So let y is equal to cos 2x is 1 over x squared. Ln y is equal to 1 over x squared ln cos 2x. And I have to find the limit as x goes to 0 plus, or x goes to 0 ln y. Now, yeah, okay. Let's see what we get. I didn't try that one. It's the limit as x goes to 0 of ln y is equal to what? The limit as x goes to 0 of 1 over x squared ln cosine 2x. This is the limit as x goes to 0. Well, let's write them. Let's write it as a quotient, right? Because this is infinity and this is 0. So I cannot apply L'Hopital's rule. But if I write it as a quotient, I will be able to. Ln of cosine 1, it's ln of cosine 0 is ln of 1, which is 0. And x squared over x squared, and x squared as x goes to 0 is 0. So I can apply L'Hopital's rule. Differentiate ln of cosine x, so it's 1 over cosine 2x times minus 2 sine 2x over 2x. Really, do you need L'Hopital's rule here, or you can do without? Do you need L'Hopital's rule here? Can we see that the answer is minus 2, right? Did we get e to the negative 2? Yeah, can we see that the answer is minus 2 on this one? Ln y is minus 2 without resorting to L'Hopital's. So 1 over cos 2x, where does it go? 1. The minus 2 stays minus 2, right? Now sine 2x over 2x as x goes to 0, where does that go? Sine something over something as that something goes to 0, where does it go? 1. So we can just use it here, right? I mean, it's not bad. I mean, do you want to do it with L'Hopital? Do you want me to do it with L'Hopital, or that's fine? Doing it with L'Hopital is fine. It's not going to be any harder. It's not going to be harder, so I'm going to make it easier. So I'll do it with L'Hopital, although you don't need that. So this is just the limit as x goes to 0 of minus 2 tan 2x over 2x okay, this is 0 over 0. Apply L'Hopital's rule again. So you get the limit as x goes to 0 of minus 2 secant squared x, secant squared 2x over 1, and you get minus 2. Okay, so the limit of ln y as x goes to 0 is minus 2. Hence, the limit as x goes to 0 of cos 2x over 1 over x squared is the limit of y, which is the limit as x goes to 0 of e to the ln y, which is e to the minus 2. Okay. Are we good here? Are we good? Please practice this. Oh, we still have 10 minutes. Any questions on this? Any questions or not? If you have questions, please don't hesitate to ask. We got this? Everybody would try to got this? Yeah. Awesome. Let's do one more. What do we have to do? I don't think we have time for curve sketching, but we do have the time for an optimization question or a relation rate question. Find the closest point on the curve x squared minus y to the point 3, 0. Oh, it's find the closest points. On the curve, what is that? X squared minus y is equal to 0?
Yes.
X squared minus y is equal to 0 to the point 3, 0. Oh no, that's the closest point. Okay. Great. So what is it? What do I have to minimize? We have to look at the distance, the square of the distance, right? If I want to minimize the distance or maximize the distance, I can just maximize the square of the distance or minimize the square of the distance. You agree with this, right? Because the distance is a positive number and the square function is increasing on 0, infinity. So we have to maximize. We have to minimize in this case. Minimize. What's the distance between a point x, y and the point 3, 0? It's x minus 3 squared plus y squared if x squared minus y is 0. Now, how many variables do I have in the function I want to minimize or maximize? Everybody, how many variables do I have? 2. Can I get rid of one of them? How can I do that? By using the fact that y is equal to x squared. Y is equal to x squared. If y is equal to x squared, what is that equal to? This is just x minus 3 squared plus what? Plus x squared. Squared, since y is equal to x squared, which is just x minus 3 squared plus x to the 4. I hope it's going to be something nice. You can do it the other way, I guess, but yeah. So let f of x 3x minus 3 squared plus x to the 4. Let's see what we get. What is f prime of x? It's 2 times x minus, oh my god, no way. Plus 4x cubed. Did we get this? So let me put x is equal to root y. If I put x is equal to root y, does it change? No, I don't think it changes, right? It's the same thing. Does it change? Anyone try with x equal root y? Were you able to factor this or not? Oh, you were able to factor it. Oh, sweet. Okay, great. Why am I worried? So it's 4x cubed plus 2x. Oh my god, 4 plus 2 minus 6 is 0. So 1 is a factor, right? So x minus 1 is a factor. So you have x minus 1. Oh, that's sweet. That's sweet. Great. Great. I cannot make bad problems. This is minus 1. So let's see. Well, you can do it two ways. So it's 6x plus 2. So no, that's not good. I mean, you can factor it. So here you can have a 4. Great. You have a 4 here. 4x squared plus 6. And how many x's you have? So plug in x equals 0, you get minus 6. Well, that doesn't help. Plug in x, I don't know, let's see. Let's plug in x equals 2. If you plug in x equals 2, you get 1 here. Just a second, folks. It's 32 plus 4. 32 plus 4 minus 6, so it's 30. So you get x equal to 16 plus 6. Is that good? You got this? Is it 10? Let's see. So let's see. So 16 plus 6, 22. 22. Oh, is it bad? Well, what number? 4? Let's see. If x is equal to 2, what do you get? What do you get here? If x is equal to 2, 32 plus 4 minus 6, 30. So here, 16 plus 6, 22. 22, 8 is left, so you get 4. Yeah. Okay, great. Now, let's look at this one. Does this one have any roots? Does 4x squared plus 4x plus 6 have any roots? Does it have any roots? No, right? Why is that? So f prime of x is equal to 0 implies that x minus 1 minus 4x squared plus 4x plus 6 is equal to 0. So this implies that x equal 1 or 4x squared plus 4x plus 6 is equal to 0. Now let's look at discriminant. Delta is 16 minus 4 times 4 times 6, which is strictly negative. So this has no solutions. You agree? B squared minus 4ac is negative. Great. So here what I'm going to do, I can do my first derivative chart. I have f prime. F is a polynomial, so it's defined everywhere. The only critical number is 1. Great. Let's look at this. Plug in a number strictly less than 1. Plug in 0. This is positive, and this is negative. So f prime is negative here. 0 here. Plug in a number bigger than 1. You get that this is also positive. Great. So f is decreasing and then decreasing. And it decreases until it reaches f of 1, right? And then goes up. Hence, f of 1 is f of 1? F of 1 is 1 minus 3 squared. Well, f of 1 is the absolute minimum of f on R, right? And hence, what is the closest point to the curve? The closest point to 3, 0 on the curve x squared minus y is equal to 0 is the point. So if x is equal to 1, what is y equal to? Is the point 1, 1, right? X is equal to 1 implies that x squared minus y is equal to 0. This implies that y is equal to 1. And the distance is it's the square root of f of 1. Okay, this is the distance. Here we look at the square of the distance. Now the square root of f of 1, what is that? It's just the square root of 1 minus 3 squared. So this is just square root of 2 squared plus 1 to the 4, which is just 2 squared. Okay, you can expect things like that. These are very nice things. Okay, so I'll post more problems. Now again, you can just ignore them or you can like benefit by doing them. Okay, so see you on Friday. I think, okay, so